Well, good afternoon, everybody. It's very nice to be back in Khabarovsk after, I think, 4 years away. I haven't been here for 4 years, so it's very nice to be back and see so many familiar faces and some new faces as well. I'd like to thank Professor Luchkova for having me here and arranging the lecture. I know that the Young Architects Forum has also done this together with you. You've set up a very nice room. I'm very pleased to hear the name Business Incubator. It sounds a fantastic new facility for the university. And I think having universities working with business is a very good thing. So congratulations to you on that. Today I didn't actually think I would be speaking for so long, but I see we have 1 hour and a half. So I'm going to talk about all sorts of things. I thought the best subject, I've called it Possibilities for Structure and Architecture. I see it says here, Professor. I've actually stopped teaching at a university now. I used to teach with Professor Seki, who's sitting here at Kantorgakuin University. Mainly now I'm just working in my office, which is called Structured Environment. It's a small business, but I have four staff in Japan and 4 staff in the UK, so it's a small business working in Japan and the UK. So today I'm just going to talk about some of the projects that I've done as a practicing structural engineer, some of the ideas that I've tried to use when designing buildings with architects. So I hope it will be interesting. I think there are a lot of architects here today to hear some ideas from an engineer. So I'm going to talk about some projects, but before I talk about the projects, I'm also going to talk about some of the engineers that have influenced me and helped me really to develop my own way of working. I'm not sure how you all think of structural engineering, but one of the reasons why I like doing it, and I think it's a very nice job, is because it's kind of a rare activity these days. You have quite a high technical content, and you also have a creative content. So, you talk about design. Well, engineers are also designers. We're technical designers. So it's a way to combine technical knowledge and creative, imaginative work in one job. So I think it's a very, very nice job, and it's not. For example, if you think of an automobile engineer or an electronic engineer, they also have obviously a creative element, but it tends to be working on one car or one piece of a car for a very long time, working on one piece of electronics for a very long time. In building, it's quite quick, and every building is different. So it's a rare. Yes, I'm just about to stop. Yeah, a rare job these days. We know that engineers design structures. When we're thinking about designing structures, we often take some hints from the natural world. I've just put up a few slides here to remind us of some of the fantastic structures that we find in nature. Our own bodies, our own skeletons, spiders. Yeah, I don't know whether Alexander's talked about the skeleton, the web, and the snowflakes, but all around us there are an infinite variety of structures that we can take hints from. But when we then come to make our own building structures, there are other man-made structures that we could look at. For example, furniture. There's a folding bike. I love cycling, so I have a folding bike. I don't know whether many of you do. Airplanes are very beautiful structures, and something that we can also get a lot of ideas from. And the other, these are kind of, what should we call them, background comments before I start on too much detail. But often when I was teaching in Japan, I found that there was a bit of confusion between what scientists do and what engineers do. Because scientists are looking at the natural world and trying to find laws or rules to explain it. Whereas engineers, they're not looking at nature, they're trying to make new things, or think up new things, conceive things that have never existed before, think up a new object. So there's no, the difference is really in science there generally is a correct answer. In engineering, there's not. One engineer will give you one answer, another engineer will give you another answer. It depends on the engineer. I found that sometimes that's confusing, especially for when I meet school kids sometimes. That in the UK and Japan was one problem. I think engineers, sometimes people think they have a white coat on and they're in the laboratory all the time doing experiments, but it's not really like that. Of course, engineers do some experiments, but they don't do experiments in the same way as scientists do experiments. So we have that creative side and technical side, and we have the idea that there's no correct answer. I like this slide. This was a project done by some students in Helsinki, and they designed and built an observation deck. I mean, it's a very simple building, just going up onto a platform to look out of. But it's a very creative piece. A lot of imagination is used in it, but it's also very technical. It is quite complicated as a structure. So that's why I think it's a very nice job to, if someone asked you, can you make me an observation deck, to be able to produce something like this, which is very highly designed technically, to make sure that it's safe, to make sure you know where all of the forces are going, and that it doesn't blow over, that it doesn't collapse when there are a lot of people on it, but at the same time come up with a very new form for building. That's a very nice activity, a very nice job. So that was one of the reasons why I decided to do structural engineering as a job. And one of the, I mean, looking at those sorts of things was one of the reasons I still like doing structural engineering. But there have been a lot of engineers who have influenced me when I was thinking about becoming an engineer, and also as I've started work on my own. I'm just going to run through, there are maybe 5 or 6 people who I just want to introduce you to. Maybe you haven't heard of them. This guy, Thomas Telford, is well known in the UK because he's a British engineer. You can see he's working over 200 years ago, really, and in his age, there were no railways yet, really, not very many roads. His transport system was canals, and he was a builder of these facilities for boats, so boats could go along man-made canals. This is an aqueduct in the background in this picture. The aqueduct in the back of the picture is still in use. You can hire a boat and go on a holiday trip across this aqueduct in Wales. And it's made of iron. This is made of cast iron on stone supports, stone piers. I think when I was maybe 15, we went on a family holiday. This is my dad walking along the side of the boat, and we went over this very high aqueduct. And it made a very big impression on me, looking over the side to quite a big drop, 30, 40, 50 metres, I'm not sure how high it is. It's a very impressive structure, and it's built, as you can see, in 1805. So it's amazing that the structure is still perfectly okay, perfectly safe after 200 years. Brunel is a bit more famous for us. I don't know whether you've heard of Isambard Kingdom Brunel. A little bit more of a modern engineer. His age was already the railway age, so railways were being used to transport people and goods. One of his famous railway bridges is this Royal Albert Bridge, which uses these arch members together with a suspension system. This is a self-balanced arch and a suspension in a self-balancing unit. So these were lifted up from the river to make the railway bridge. And this is also still used as a railway bridge today. So I suppose for me that was one other thing that I found quite attractive in a funny way. If I've spoken about the technical side and the creative side, the other side is the responsibility, and the always at the back of your mind you've got to be careful that there's not an accident, because it has a very heavy side to it. If you do make a mistake, or if something is built which is dangerous, then people can get injured or even killed, as in this on this day. 3 people did get killed. This moves us right into the 20th century. A very famous guy, Over, who was actually born in Denmark, grew up in Denmark, and then moved to London to start his office in London. His office is still a very important engineering office with about 5,000 staff. A very, very big company now. Looks like a normal sort of guy, but if you look at the picture closely, in his top pocket you can see 2 chopsticks. Even though he was living in London, he would always eat his dinner with chopsticks because he thought it was more efficient and more environmentally good. I think engineers often have a bit of an eccentric. Sometimes they're a bit mad. A bit of them is a bit mad as well. But this also appealed to me, that he was thinking about how he should eat his dinner at the same time as designing buildings. Anyway, Over, one of the most famous structures he designed is the Opera House. If you get a chance, it's a good project to read about, because there's a good story about Over's relationship with the architect, who is Utzon. This is the architect, a small picture of him, who's also Danish, and the way they worked together. Utzon's original scheme gradually turned into a more geometrically or mathematically definable scheme. The free shape became a sphere shape. Utzon wanted to win the competition, so he was doing a very sculptural, free-form scheme, but the one that was, the building that was realised, the geometry just comes from a single sphere, so all of the roofs, all of the different size roofs come from the same radius sphere to make it easier to build and easier to analyse and cheaper to build. This picture was also appealing to me. He's over on site in 1964 with his partners. You know, maybe there's been some problem on the site. I mean, it looks quite a nice job, doesn't it? These three guys have come to Sydney Opera House site and there's some problem and they're trying to sort it out. To me, it seemed as though it was, again, you know, responsibility, technically interesting and creative at the same time. And if you haven't seen the Sydney Opera House, please go and have a look at it if you can. It's a very fantastic building, and I think the appearance of it today is just as good as it was in 1967 when it was finished. It looks very, very new and perfect as a symbol for Sydney, or almost as a symbol for Australia. O'Varra was designing also civil engineering structures like this bridge. I really like this bridge in Scotland called the Kylesky Bridge. I've probably showed it to you before in concrete. It looks as though it's growing almost. It's the same colour as these rocks. It looks like it's growing out of the landscape like a plant. Mm-hmm. There's a very brilliant Russian engineer who I think you probably know, Shuhov, who designed some fantastic structures. He also looks a bit eccentric, doesn't he? Riding on this strange bicycle with a funny hat on. But he was an engineering genius. I don't really need to show you these pictures, but just remember that he did all of these, the old, not just the Moscow radio tower, but many, many towers using this system for electrical transmission across Russia. And he did many similar, Gum is the most famous one, but many roofs like this across arcades in Moscow and I think other cities. And in 1920, of course, steel was very expensive, so just using the minimum amount of material to get the maximum height for the roof, the minimum amount of material for cost, but also to let light in without anything heavy, which would make the interior dark. And if you look at the other projects that he's done, I think this is the exposition in Nizhny Novgorod. This one of the earliest types of net roofs, quite a large span net roof, many station structures, and as I say, many transmission towers. Just looking at these, it just seems that it's, he's completely free, doesn't it? He can do what, not quite magic, but as close to magic as you can get in the real world. So if you look at somebody's work and it seems this free, it seems very attractive. It seems very, very attractive to me as a job. Fazla Khan came from Bangladesh and emigrated to America, and he worked in America until he died. He worked for a big firm a big office called SOM, Skidmore, Owings and Merrill. And he was working in America when there were a lot of high-rise new skyscrapers being built. And the trouble with tall building is that it's very easy for it to be monotonous. You know, every floor looking the same, or the facade all looking the same. So Khan came up with a system where the facade looks more interesting. Normally for a tall building, offices are in the upper floors and shops or restaurants often need to be in the lower floors. So sometimes you have a lot of columns higher up, above the first floor, and then on the first floor you need bigger openings. And if you look at this building, you can see the surface is rippling like waves on the surface. Where he wants the forces to come, he makes the columns bigger. So they're here and here, the columns get bigger. So all of the force goes into the position where the columns are bigger. Tim McFarlane was, in those days, experimenting really. It was a bit of an experiment with these glass structures. And during that project, I was also able to get Tim McFarlane, my old boss in London, to help us design this glass roof as well. So it was very nice for me to work again with my new boss in Japan, who I respected, and Tim in London, and we made these glass beams in London and brought them to Japan. So it was a very, very nice project for me. I mean, if the building is, or the structure is too expensive, nobody will build it. If it looks ugly, people will hate it. And if it's not efficient, then you're wasting the Earth's resources. And these structures, in my opinion, are satisfying the aims. They're safe, they look economical, they look efficient, and I think they're beautiful. So if everything goes well, we aim to make this sort of structure. I've taken up about an hour already just talking about the kind of preparatory pieces, but these are some projects that I've designed myself, so I can talk a little bit in a bit more detail perhaps about some of these. One other structure where we used aluminium is this roof over a subway station. This is in Kaohsiung in Taiwan. Kaohsiung is famous for shipbuilding, so we made this roof, this aluminium roof, in a shipbuilding factory in the town of Kaohsiung, and then brought it to site. That's a model of it. And in Taiwan they have very strong winds because there are typhoons. So we did quite a few wind tunnel tests. This is a model in a wind tunnel. So air is blown against this model and pressures are measured using these tubes over the surface of the roof to figure out how much force lifting it up or pushing it down is on the roof. And it's finished in this picture. So that's a plated structure in aluminium, a curved plate. These legs are steel. So the aluminium piece is just on top. The columns are steel. My office has done quite a few projects with this guy, Yue Nishizawa. One of the Korean delegation this morning talked about Sana's projects, and Nishizawa is one half of Sana, but he has his own office as well as working with Sejima. And I think that the guy this morning was talking about open facades and how the inside is linked to the outside. In this project it was a small condominium really, a shared house. So four people rent units in this group of buildings and live together on the same site. But Nishizawa wanted to have very flat, pure forms. So it's almost like a piece of sculpture, really, this building. All of the walls are made from steel plates. So this is just a steel plate cut to that shape. Maybe it's easier to see there. This is the garage. I say garage, the place where the cars can park underneath the house. And this is the side view, a 2-story timber box. There's a concrete slab here, actually. Supported on these they're so thin that you can't really see them actually in this picture. These they're stainless steel posts. This one is a little bit bigger. It's a small museum for exhibiting the art of this artist, Mashimo. Mr. Mashimo. It's his memorial museum. Well, I think I've gone on very way over the time. I've probably got too many projects. It's already an hour and a half, so I'm going to stop here. And if you'd like to ask questions or anything, that's fine. So thanks very much.